Good evening, ladies and gentlemen. This is Mr. Vicari, your well-rounded math teacher, and today we're going to talk about series. It kind of leads off from sequences because a series is a sum of a sequence. Okay. Suppose a section of an amphitheater can sit 18 people in the first row, and each row can seat 4 more people than the previous row. So basically, you're adding 4 on to each row. Each row you go up, you add 4 more seats. Find the number of people who can sit in the first 5 rows. Well, in the first row, you can sit 18 people. So the second row, adding 4 to that, would be 22. Third row, 26. Fourth row, 30, adding 4 more, and the fifth row finally would be 34. Add them all up. That's what a series is. You're basically adding numbers in a sequence. And 18, 22, 26, 30, and 34 is a sequence because you're adding 4 more. It's arithmetic sequence, actually. So what do we got? 10, 16, 20. Here are the 2, 5, 7, 10, 13. 130 people can sit in the first 5 rows. In the late 1700s, Carl Friedrich Gauss was a student in a small German schoolhouse. Gauss was a bit of a troublemaker, and the teacher was fed up. As a punishment, he made Gauss sit in the corner, add up the first 100 integers, with this thought of being a very lengthy and tedious task. Gauss finished within seconds. How did he do it? Well, the first 100 positive integers, well, that'd be 1 plus 2 plus 3 plus 4 plus 5 all the way up to, what do we got, 96 plus 97 plus 98 plus 99 plus 100. And being a young grade schooler, if you would have added them up, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4, and so on and so forth, it might have taken them a long time. But if you look at this, and using patterns, I know the first term is 1, and the last term, a sub n, is 100. A sub 1, a sub n, or a sub 100, I guess you could say. First term and last term. If we add these up, 1 plus 100 is 101. How about 2 and 99? The next to the first term, a sub n, or a sub 2, and this would be a sub n minus 1. 2 plus 99 is also 101. 3 and 98, also 101. So working with this pattern, how many 101s would we have? Well, how many terms do we have altogether? 100. What's half of that? 50. So if I took 50 and multiplied it by 101, I'd have the total sum of all these numbers, which is 5,050. Well, basically what Gauss figured out was a little pattern he could use for adding up sequences. And here they are. This is the one he came up with. There's a sub 1, which would have been 1 in our last problem, and a sub n, the 100th term, which is 100 also. And then taking half of all the numbers, well, there's 100 numbers altogether, and half of 100 is 50 divided by 2 there. So 50 times 101, because 100 plus 1 here is 101. That's kind of the formula he came up with. Now there's a couple formulas we're going to use for these series. Series is a sum of a sequence. So just a little refresher here. Sequence is a list of terms. Okay? Something like 2, 4, 6, and 8. You're increasing by 2 each time. just a list of terms. Where a series, what we're getting in today, is a sum of a sequence. So the difference between sequence and series is this. Here's my sequence 2, 4, 6, 8. A series would be 2 plus 4 plus 6 plus 8. Okay? So they count summations also. Sum of first terms in the sequence. Okay. There we go. Aiden did push-ups every day in March. He started on March 1st and increased the number of push-ups done each day by 1. He did a total, this is the sum of all the push-ups he did, of 1,085 for the month. How many push-ups did Aiden do on March 1st? Okay, so basically how many push-ups did he do that first day? So we got to look at what we know and what we don't know. First of all, a sub 1, the first term. We don't know that. That's what we're looking for. We also don't know a sub n, number of push-ups he did on the last day. But we do know a few things. First of all, n. How many days did he do push-ups? Well, in March there's 31 days, so I'm going to say n is 31. And the common difference, this is an arithmetic sequence that we're going to be adding up. He's adding one more each time, so the common difference is 1. So these two formulas here basically do the same thing. This is a little more broken down and easier. This one's a little bit more complicated, but we only need to find a sub 1 here. This one you need a sub 1 and a sub 2, starting point and the last term in your sequence. So we're going to use this first equation up here. Now one thing I haven't put up here is s sub n, the sum of all these numbers. Well, he did a total of 1,085 push-ups, so we can use that. And we can use d and we can use n, and that'll help us find a sub 1. So I'm going to use this formula right here. S sub n equals n over 2 times 2 times a sub 1 plus n minus 1 times d. And the only thing I don't have here is the a sub 1. I can plug everything else in and then solve for a sub 1. So S sub n, first of all, the sum of all the push-ups is 10,085 or 1,085. 31 days in the month, that's what n is. 2 times a sub 1 plus n, well, that's 31 minus 1 times the common difference, d right here, is just 1. We're adding 1 push-up each time. So basically we're going to solve this equation for a sub 1. That first day of push-ups. 31 divided by 5 or 2 is 15.5. 2 times a sub 1 plus, well, this is 30. 30 times 1 is 30. I'm going to use the distributive property here. 2 times 15.5 is out, well, 31, just undoing what we did up here. A sub 1 plus 15.5 times 30 is 465. So, finishing this up, subtracting 465 from both sides, I get 620 equals 31 a sub 1. So to solve for a sub 1, I'm going to divide both sides by 31, and I get this. How many push-ups did he do on the first day? A sub 1 is equal to 20. Second day he did 21, third day he did 22, so on and so forth, all the way up to March 31st. So there we go. First time we use this formula. Oh, crap. That's right, we're fine. Cities 97. Okay, what are we doing here? Radio station is giving away a total of $1,240 or $124,000, sorry, in August. If they increase the amount given away each day by $100, how much should they have given away by the first day? Okay. So A sub 1, once again, we don't know what that is. A sub n, the last day. I don't know what that is either. But I do know this. How many days are going to be giving stuff away? Well, in August, there's 31 days. So that's your n. Common difference, it's coming up by $100 every day. And they gave away a total of $124,000. So S sub n equals 124,000. So what I want you guys to do is this: increase each day. How much should they give away that first day? We're going to look for A sub 1 again, and I'll give you a hint. We don't know A sub 1 and A sub n, so I'm not going to use this formula right here. We're going to use this one again. So S sub n equals n all over 2 times 2A sub 1 plus n minus 1 times d. So you guys plug in n, d, and S sub n, the summation, and you should get this. A sub 1 equals, you can hit pause now and try it and check your answer when you're done, or you can just do this, 2,500. So you try it. You plug it in and see what you come up with. And we will finish these notes tomorrow in class. So go ahead and try it. We'll see you then. Bye. One thing here, don't forget to take your quiz, okay? Don't forget your quiz.